So we've spent a decent amount of time talking about forces and how to calculate acceleration of objects and tension in ropes and things like that. But to be honest, it's not incredibly common that you have forces that only act directly horizontally and directly vertically, right? It's much more likely you're going to have forces acting at some angle. Even when I, pull on this eraser, pull it this way, I'm applying a force that's certainly sideways, but I'm also pulling up slightly. It's very rare you're going to have exactly to the right or left or exactly up or down. So to calculate forces in 2 dimensions, let's take a really simple example. Let's say we have a block. And this block is on a ramp, okay? An inclined plane. So I'm going to say my block is here. It has a mass of m, and that's pretty much it. And I want to find the acceleration of the block. Find A. Well, what do? Clearly, there's a force of gravity down on it, right? If we draw the free body diagram of this object, I actually like, and this is totally personal preference, I like keeping it on here, and I can see it pretty visually. So we have a free body, an arrow down representing the force of gravity, which is mg, right? But that doesn't help. If this angle, I'll call it theta, is not 0, which is clearly not here, it's on a ramp, then what force is making it go down? Somehow gravity is pushing this block down, even though gravity only points vertically. How is that happening? Well, recall that forces are vectors, right? And vectors can be broken into components. So that is actually what we have right here. So what we're going to do is we're going to choose for our coordinates, right? We're going to choose our x and y axes to be slanted by an angle of theta. So I'm going to choose, this is going to be y, and this is going to be x. So crooked at the same angle of theta as the ramp. So I need to then break this down into components that align along the x and y axes. So I need to find a component like this, and I need to find a component like this, and this is a right angle here. So that's great. What that means is I need to figure out one of the angles inside this big triangle. So this angle is theta, and this is 90, so that means this is theta minus 90, which means this is theta minus 90. This little one is also theta minus 90, which means this big angle here is theta. So recalling how to break things into components, what we have, taking this triangle over here, we have mg, and that's pushing down, right? And then we want to find this side. So actually, let's just keep it all in one diagram. So I have mg pointing down, and I want to find the opposite side. So this side is opposite the angle. So this is going to be mg times the sine of theta. This side, this horizontal, vertical according to our components, is going to be adjacent, so mg cosine theta. So now what we can do is we can write down force equations that match these coordinates. So the sum of our forces in the y direction is equal to, well, we have mg cosine theta, and we also have the normal force, which is the same thing back up, mg cosine theta. So this is going to turn out to be 0 and is not interesting to us. And this, again, is pretty much what we're used to, right? Where we have objects on a flat surface, they don't accelerate up or down. Even though this is accelerating down with respect to the normal coordinate system, x and y, with respect to our coordinates, it's not going like this at all. It's not moving up or down. It's only moving horizontally. It's only changing its x component, our version of horizontally. So the sum of forces in the x direction is going to be, well, we have gravity, mg sine theta, and we don't have any forces opposing that. So we can just set that directly equal to ma. Which means if we want the acceleration of the block down the ramp, we'll divide both sides by m, and we get a is equal to g times the sine of theta. And that's it. So this is how you solve problems that have forces in 2 dimensions. You need to choose your coordinate system in such a way that you're going to align with the direction that the forces are acting on the block. And after you do that, everything else is the same. That's the tricky part. The tricky part is figuring out what direction the coordinates are in, breaking it down into components, and then going ahead and solving.